Hey everyone, welcome to the iCode, and today we are going to take a look at 2405 optimal partitioning of the string. I'm going to do this using Python. This is today's Leetcode challenge, and let's get started. Let's take a look at it. So I'll give you the overview of the problem, and then we'll go through the intuition, and then I will try to code it up, right? So what is given is a string with the characters, and then they ask is partition the string into one or more substrings such that the character in each substrings are unique, right? That means this cannot be the substring. All the characters in the substring should be unique, so A and B can be a substring, and that is no later appear in a single substring more than once. That means we shouldn't have the duplicates. What they are asking is return the minimum number of substring in such a partition. So we partition where we don't have duplicate letters in any substring, and they want us to return the minimum number of partitions, right? So let's take a look at this example. Also note that each character should belong to exactly one substring in a partition. Again, the same thing, it's there should not be duplicates. So let's take a look at this example. Here they have given two possible partitions are A, B A, C A B, and A. So we see like there are no duplicates in any substring, and there are four partitions like that. But this we can do it this way as well, where we have A B, then we have A, and then we have CA and BA. Like you can do a lot of I think few more combinations, but we need to return the minimum, right? So minimum is 4 here, minimum is 4 here, 4 partitions. Right now take a look at this one. So this is S, so there is no way that I can have less than 6 partitions, right? We need to have 6 because all the letters are same. So this is we have um, 6 partitions. I'll walk you through how we'll do this. So this is again a greedy problem. So at particular sub problem you try to get the best solution, and that would lead to the best overall. So suppose I'm starting from A here, and I need the minimum number of substrings, right? So that means I want to have longer the substring is the better, so that would result into minimum number as long as we don't have duplicates. So I'm starting at A, and then I would maintain one scene set which would contain scene, right? So I have scene A right now, right? And then I go at B. Do I have I seen B? No, so I just add B here. Again, now I go at A. Yes, I have seen A, right? So in that case, what I'm going to do is increment the answer plus equals 1, right? So that okay, I have found one partition. This is going to be one partition. I have to break at this point no matter what, because we cannot have duplicates, right? And then I reset AB again, scene again, and then I add A, right? This is my second partition now. A, right? We added A and then incremented by 1, and then I'm at C now. C, have I seen C before? No, so I add C. Okay, A, I have seen A again, so I go ahead increment this. So till now, till this point I had 2 partitions so far, right? And this is the start of the new partition. So I'm just gonna reset it, because this scene I have to maintain it for each partition, right? So we reset it whenever we find the character in the scene. We reset the scene and increment the answer. Then I have seen A right now, and then have I seen B? No. So I go ahead, update the B. Again I'm at A. Oh, I have seen A before, so right, I do and increment this one. So answer is gonna be 3 right now. We have seen 3 partitions, and then reset, right? And now I add A, right? And then I get out of the loop. But in the end, see how I incremented it 3 times when there is this one again, which is the last partition, which we didn't get a chance to update answer. So I'm going to return answer plus 1, right? So I hope that walkthrough makes sense, and then let's code it up. So first I'm going to declare is a set, scene equal to set, and then answer, this is what I'll return. so that's going to be 0. And then now iterate through the string, right? For I'm going to use enumerate, but let's see, in indices and val in enumerate of s. So what enumerator does is it's going to give me the index and the value in the s at a time, right? In both these index and value variable. So now see, if val in scene, so that's what means that I have seen this character again before, and I'm gonna reset my scene, and this is going to be the next this I have reached one partition. That's what it means, right? So we update answer plus equals 1. But see, I have seen a once, a before as well. I came at a again, and I have resetted this, but I still have to make sure that I add a. So anyways, we add scene dot add whatever is the current value, we anyways add it. Suppose I haven't seen val already, then I just go here, right? It's the continuation of the same. Suppose we are at b and I haven't seen b so far, then it's a continuation of the same partition, so we don't need to increment answer and just add b into the scene. So that's what we do, and in the end, return, once the for loop is complete, we return answer plus 1. And this is it. It's pretty small. This is medium problem, but I think it's pretty easy. Okay, it works. 4466, and let's submit. Yep, 45, not so good, but yeah. Memory and time complexity wise, worst case scenario, if I have a b c d, that's my string, then scene is going to be scene is going to contain everything a b c d, right? And that's going to be O of n memory, worst case scenario, right? Memory is O of n. And then yeah, time complexity is O of n as well, because we are iterating over the s. So time is also O of n. And this is it done. If you like the solution, if you like the content, please like and subscribe. If you have any questions, comments, suggestions, let me know in the comments. Thanks.